There are horizontal asymptotes, there are vertical asymptotes, but there are also slant asymptotes. And they are slanted just like it may sound. They're still a straight line, but they're not exactly horizontal or vertical. Just to give you an idea what it looks like, if you see that graph over there, the blue is the actual function. The red line shows where the slant asymptote is. Now, for there to be a slant asymptote, the biggest exponent in the numerator must be exactly one bigger than the biggest exponent in the denominator. So this happens with rational functions. Another way I could say this is for there to actually be a slant asymptote, the degree of the numerator must be exactly one bigger than the degree of the denominator. So let's check out an example. We need to know how to find them. So find the slant asymptote for 2x squared minus 3x plus 1, all divided by x minus 2. So to find them, we've got to use division. If you can use synthetic, go for it. If you have to use long division, use long division. I have videos on both of those if you need it. But on this one, we can use synthetic. So I am going to assume you know how to do this division. I'm just going to solve this particular problem. So I need to look at what would make the denominator equal 0, and that would be 2. So I put that in the box, then I take the coefficients, 2, negative 3, and positive 1. I bring down the 2. I do 2 times 2, which is 4. Add those together. 2 times 1 is 2. Add those together. I get 3. I started up here with an x squared, but I've divided by x, so that reduces my first term to x to the first, makes this a constant, and then makes this last part the remainder. However, when we're finding a slant asymptote, we don't care about the remainder. In fact, we throw it out. So our final answer is that the slant asymptote is at y equals, make sure you put that because this is an equation we're finding, y equals 2x plus 1. So the slant asymptote just means you have to divide, but ignore the remainder. Let's try another. So when you're asked to find a slant asymptote, your first thought should be, is there one? You need to make sure you check to see if there is actually a slant asymptote. And on this one again, there is, because the degree in the numerator, 2, is exactly one bigger than the degree, 1, of the denominator. Thankfully, this is another one we can use synthetic division. So I'll just say, okay, what would make the denominator 0? That would be negative 4. I put that in the box. Then I take on the coefficients I see, 4, 6, and negative 37. I bring down the 4. Negative 4 times 4 is negative 16. Add the 6 and negative 16 together, I get negative 10. Negative 4 times negative 10 is 40. So I get a remainder of 3. So I started with a squared. I've divided by x, so this first term is going to be an x. The negative 10 is my constant. The 3 is my remainder, but I don't care about the remainder. I want to make sure I do not include the remainder in the slant asymptote, or it will be wrong. The slant asymptote is at y equals 4x minus 10.